All right, so let's learn by doing. So go ahead and take a couple moments and read this example that you probably would have seen in Stat 251. Welcome back from your reading. Thank you for taking some time. And so if I was reading this, one of the things I would want to highlight, okay, is this 70% of adults, okay, in the United States. It's a nice thing to recognize. The next thing I would want to highlight is believe in global warming. Either they do or they don't. Okay. I'll put that. I'll highlight that as well. Okay. Sample was taken 1,504 adults from various parts of the country. I'll highlight that, and I got ahead of myself. It's a random sample. I'll highlight that. Upon further review, observe proportion is higher than thought. So this is from the sample, okay? Boom. And then indicating that 75% of the students, 75% of the students, of the adults believe in global warming. Okay, boom. All right. So then I'm asking you to construct a 95% confidence interval to estimate the population proportion of adults in the United States who believe in global warming. All right, so that's cool. Okay, that's fine. Ideally, you would have seen this before, but I can imagine you could have forgotten. And so what we're going to do is this process called SSVA, and I'm going to use SSVA throughout the entire class. And SSVA stands for Summary Statistics, Visualizations, and Analysis. Okay, so with that being said, why don't you again take a moment and review summary, statistics, visualization, and analysis. Okay, so when I'm reviewing the summary, statistics, and visualization and analysis, some of the things that I would want to note, okay, is that my sample size is 1,504. That tells me that 1,120 individuals believe in global warming from my sample. Which of these concepts is random? Is random in the when dealing with statistics? That's interesting. Which of the concepts is random? X is going to be random. We have a sample size, right? We have some sample. Well, our X is unknown. It's going to vary from sample to sample. Okay, that's what I'm after. My apologies for the language issue. Sample proportion, aka the sample statistic. So the sample proportion is more specific, whereas the sample statistic is a general idea. P hat is 0.75, and this information is given to us within this description. Fantastic. Going from there is a visualization. When it comes to categorical, this is a categorical binary variable. If there were more than two options, three or more, essentially, you would want to call that categorical. It would be that big categorical variable. But when it comes to categorical or categorical binary variables, I'm doing that intentionally so that you can remember that. You would want to visualize it using a bar plot. So we have the proportion of those that believe and proportion of those that don't believe. Okay. Again, this is a categorical variable. How many variables do you see here? How many variables do you see here? One more time. How many variables do you see here? You only see one. Okay. There's only one variable. Each, observational unit in a U.S. adult will be just, measured in the sense of if they believe in global warming or not. So that makes it a categorical binary variable, one categorical binary variable. Okay. And then here's our analysis. This is a lot of information that we already kind of went over. This is our output. You won't be learning R in this class. We'll be just using R to provide us analysis, to do our analysis for us. Okay. This tells me the number of successes, 1,128, which is what we got earlier in our summary statistics, right there. Okay, it tells me my sample size, 1,504, and my sample proportion. We'll talk about how the standard error is calculated in a little bit. Okay, it gives us a confidence interval. We're able to input that, but that's not going to be highlighted in this class. It asks us to create, it doesn't ask us to create, but it provides us our critical value based on our confidence level, and then it gives us our lower bound and upper bound. So this is where I'm being really intentional in how I'm organizing this class, in that we did the description, we did the SSVA, and now you're going to take some time and answer those questions. So go ahead and take some time and answer those questions. All right, so these questions are going to be new for me as well. So I'm assuming that you paused the video when you're answering the questions. All right, so or you've already answered and you're double checking your work, okay? So what's the population of interest? Describe the sample, state the observational unit, okay? So the population of interest should be all U.S. adults, okay? The sample is going to be the 1,504 U.S. adults from the previous parts of the country, from various parts of a country. The observation unit is just going to be a U.S. adult. I prefer a U.S. adult, but I know a lot of instructors might have said the 1A each U.S. adult, okay? That's that. Oh, wow. I need to press enter after that. Okay, good. All right, so what is the variable of interest? We already mentioned this before in the previous part of this video, and that's going to be whether they believe in global warming or not. And that's going to be a categorical binary variable. Hopefully you all were able to mention that. Okay. Good. Continuing on, what is the research question? So the research question, you have to go to the description and tap it. They're asking what is the population proportion? Okay, where is it? It's more so when they ask you for the estimate. I'm going to take that as a question right there. Estimate the population proportion. Okay, that's going to be our statistical question, which indicates that we should be doing a confidence interval. If it gave us a hypothesis, it gave us a claim, if it gave us an idea, that's when we would do hypothesis testing. Whereas in this situation, it doesn't give us an idea. It has some said value, but it's telling us to estimate the actual proportion. Okay. So here it says, what is the population proportion of U.S. adults that believe in global warming? What statistical technique are you going to use to answer this question? It's going to be a confidence interval for one population proportions. So what you should be familiar with at this current juncture is one population proportion confidence interval, one population proportion hypothesis test, one population one population mean hypothesis test, one population mean confidence interval. Okay. And so what assumptions need to be made is that p hat times, so I got ahead of myself. So it's random sample, a random sample. I'll write that in, a random sample. And it's always going to be an assumption. And then n times p hat is greater than or equal to 10. And n times q hat is greater than or equal to 10, where q hat is equal to 1 minus p hat. Okay. And so in this situation, p hat was equal to 0.75. So this is going to be 1128, I believe. 1128. And then whatever 1504 minus 1128 is, that's going to be your n times q hat. All right, what is the parameter of interest in the context of the description? What is the statistic used to estimate the population parameter? Describe what the value is. The parameter of interest is going to be the population proportion of the U.S. adults. Okay, what is the statistic of interest? Is going to be the sample proportion of U.S. adults that believe in global warming. My apologies for not saying that earlier. And describe what this value is. It's going to be just 0.75. Okay, so you use P for this parameter, and you're going to use P hat. Okay, is equal to 0.75, and this is our description of what P hat is. A point estimate is a single value best guess of an unknown parameter. Okay, so P hat is our estimate of P, and the sample, based on the sample, state the point estimate. And so the point estimate is just going to be 0.75. Okay, it's not nothing too crazy. Our standard error, we have an equation. Okay, we have an equation, square root of p hat times q hat. I wish I can press enter before it shows it. But yeah, there we go. P hat times q hat over n, square root of that. And so this is the math for that. So what this allows us to measure is how our statistic, p hat, is going to vary from sample to sample. How our statistic is going to vary from sample to sample, which is going to be on average 0.0112. It's going to deviate from the actual true population proportion at 0.0112. All right, so our level of confidence is a measure in statistic that quantifies the certainty or uncertainty of an estimate. And so when we say 95 or 99%, that's a measure of our confidence, okay? In which we believe the actual statistic will fall in between, in which we believe our population parameter is within based on our sample statistics, okay? So here, we'll use the critical value to denote the level of confidence, draw this conceptual concept on the bell-shaped curve. What that means is that if we were to draw this, let's see, not insert, but draw, my critical value would be this vertical line here. That's a curve, it should be straight, okay? This is my critical value, CV, and this is going to be a negative CV, and this is going to be my positive CV, okay? And then this area underneath, let's highlight this area. Let's do back. Let's make this a different color. We believe that we're 95% confident that my population parameter, my population proportion of U.S. adults that believe in global warming is going to be in between this value and this value, okay? So that's that. The margin of error is a statistic that represents the amount of random sampling error in the survey results conditional on the level of confidence and the level of confidence. So at the end of the day, it's just your critical value times your standard error. And that's how we would find it, okay? That just measures the amount of error that we should expect when it comes to random sampling, okay? So that's why we multiply our critical value times our standard error, and we get 0.0219. Okay, so in statistics, the lower bound and upper bound are the smallest and largest, respectively, that form the plausible values within which a population parameter, in our case, the population proportion, is expected to lie. So this is our explanation, and then this is the math behind it. Point estimate, which is what we found, which is our 0.75, plus or minus our margin of error, which is what we found to be 0.0219. So we add 0.0219 to 0.75, that's going to be our upper bound. And when we subtract, that's going to be our lower bound. Okay? And that's the math here. Okay? So that is what we have for this problem. Now, the most important part, interpretation of a confidence interval provides a range of plausible values derived from our statistical analysis of the sample that is likely to contain the population parameter we are interested in. The width of the confidence interval gives us some idea about how certain we are about the unknown population parameter. So one thing to emphasize here, which could show up on a quiz, is that if we were to change our sample size, okay, sample size is going to have an impact on our range of plausible values. So the bigger the data, the narrower our sample size is. The smaller the data, the more variability we should see. So that should kind of make sense in terms of data. Whereas if I were to increase my confidence, right, if I increase my confidence, I'm going to have a bigger range of plausible values. Where is that? Right here, this part. If I have a 95 compared to a 99%, I should see more values. Whereas if I go from a 95 to a 90% confidence interval, it's going to be the plausible values is going to shrink. So it's important for you to note that. Okay. Finally, in terms of interpretation, we are 95% confident that the population proportion of U.S. adults that believe in global warming is in between 0.728, which we found here, and 0.7719. Okay? All right, so that's it for this part. We have another part in this video. Quick review. Okay. I don't have time for a review. You can rewind when you need to. How hard was that? Give me on a scale of 1 to 10. How hard was that? Speed doesn't matter because you can rewind it. So, how hard was that? Go ahead and tell me in the comments. And please like and subscribe. Ha ha ha.